positive and negative, above and below. We use these ideas all the time, probably without even thinking about it, especially when we're just, say, checking the weather. But these simple concepts, they're the key to measuring absolutely everything, from a crisp fall morning to the deepest, darkest point on Earth. So let's dive in.
Okay, so take a look at this. On the very same evening, it's 3 degrees in Memphis. Cool, but not too bad. But then look over at Bangor, Maine. It's -17. That is a huge 20-degree difference. So what's the first thing you notice here? What does that little minus sign really change?
That tiny little minus sign is doing all the heavy lifting here. It tells us we've crossed a really important line, that we're now in below zero territory. But what does below zero actually mean? To really get it, we're going to need a kind of map. And that map is the good old number line. For what we're doing right now, just picture a thermometer that's been tipped on its side. It is the perfect tool for watching how these temperatures go up and down. All right, let's start with a nice, simple one. We kick things off at a pretty pleasant 5 degrees. Then the sun really starts shining, and the temperature climbs up another 6 degrees. So on our number line, where do we end up? Yep, we land right at 11 degrees Celsius. It's just simple addition, and we're staying on the positive side of zero the whole time. But what happens when the temperature drops and just keeps on dropping? Okay, now for something a little trickier. Imagine it's 8 degrees at midnight, and then a big cold front rolls in, making the temperature plummet by 12 degrees. This time, our little journey on the number line is going to take us right across that critical zero boundary. So let's track this drop together. We start at +8. Now, the first 8 degrees of that drop take us right down to the zero mark. That's the freezing point. But we still have 4 more degrees to fall, and that's what pushes us into negative territory. And there we are. We land at -4 degrees Celsius. By dropping 12 degrees from 8, we blew right past the zero line and ended up 4 whole units below it. And that right there is the whole idea of negative numbers in action. So this above and below zero idea, it works perfectly for temperature. But what if we took that exact same logic and applied it to the physical world around us? Let's switch from decoding temperatures to finding our level with elevation. Now, in this new context, our zero isn't the freezing point of water anymore. Instead, it's sea level. You can think of sea level as the universal baseline we use to measure every high and every low on the entire planet. It's basically Earth's ultimate zero point. So, if sea level is our zero, then elevation is just the distance you are from that line, either up or down. Anything above it, like a mountain peak, gets a positive number, and anything below it, like a deep valley, gets a negative one. Simple as that. And this applies to real places you can actually visit. Check out Denver, the mile-high city. It's way up there at over 5,000 feet. Miami, well, it's sitting right at zero. It's a sea-level city. But then, look at New Orleans and Death Valley. Whoa, they have negative elevations, which means they are actually below the surface of the ocean. Yeah, let's zoom in on Death Valley for a second. The table shows its elevation is -282 feet. So when you see that, what's it really telling you about where it is physically? Exactly. That minus sign isn't just a number, it's a direction. It tells us that Death Valley is literally, physically, 282 feet below sea level. No wonder it's one of the lowest and hottest places on Earth. Okay, so we've seen how this works for cities. Now, let's push this idea to its absolute limits. We're going to use these positive and negative numbers to visit the highest peaks and the deepest trenches on the entire planet. First, let's look at the highs. I mean, look at Mount Everest, just towering over everything else at a staggering 8,848 meters above sea level. These are the positive extremes, the absolute highest points on our world. And now for the complete opposite. Let's go to the lows, the deepest parts of our oceans. The Mariana Trench plunges to negative 11,033 meters. That minus sign signals a journey down, way, way down, far below the surface of the sea. And this brings us to a really fascinating question. We've got this huge positive number for Everest and this massive negative number for the Mariana Trench. But which one represents a greater distance away from our starting point, from zero, from sea level? And this chart gives us the answer. And it might not be what you think. See, if we're just measuring pure distance from zero from sea level, the signs don't really matter. And at over 11,000 meters, the Mariana Trench is actually farther away from sea level than the top of Mount Everest is. How wild is that? So, from a cold day in Maine to a valley below the ocean surface, all the way to the deepest trench on Earth, there is one single powerful idea that connects every single example we've looked at. And this is it. This is the big takeaway. The meaning of a negative number totally depends on what zero means in that situation. Zero isn't just an empty space. It's the anchor. It's the reference point that gives all the other numbers, positive and negative, their real power and their meaning. When you really think about it, it's an incredibly elegant system. This one simple concept, a number line stretching in two directions away from zero, lets us describe and measure our entire world, from the everyday stuff to the most extreme. But before we go, let's put these ideas to the test with one final little puzzle. It's got a spider, a simple pattern, and our new best friend, the number line. So get this. A spider starts at sea level at 0. It climbs up 1 inch, then drops 2 inches. Then it climbs up 3 and drops 4. You see the pattern. If this keeps going for 1 full hour, what will its final elevation be? I'll leave you with that one to think about. Because really, the world is just full of patterns like this, all waiting for you to discover them with the simple power of numbers.